Hello viewers, you are welcome to my YouTube channel Mathematics Made Easy. In today's video, we'll be generalizing a logarithmic integral here. That is generalized logarithmic integrals. So we are going to do this one for today, which is integral from 0 to 1, natural log of x raised to the power of a over 1 minus x dx. So we want to prove is equal to minus 1 raised to the power of a multiplied by a factorial multiplied by the zeta function of a plus 1. Alright, so before I dive into the solution, don't forget to subscribe to my channel. Please like and share. Thank you. So let's dive into the solution. Now, let's start. So for us to prove the integral 0 to 1 of natural log of x raised to the power of a over 1 minus x dx. So we want to prove is equal to minus 1 raised to the power of a multiplied by a factorial multiplied by zeta function of e plus 1. So how are we going to solve this question? It is very easy problem. Okay, so I'm going to use sum series in solving this problem. Now we know 1 over 1 minus x is equal to summation of n from 0 to infinity of x raised to the power of n. So since I already know that 1 over 1 minus x is sum of n from 0 to infinity of x raised to the power of n, so I can rewrite this integral as integral from 0 to 1 natural log of x raised to the power of a. So instead of 1 over 1 minus x, it's now sum of n from 0 to infinity of x raised to the power of n dx. Then I can bring out the summation. So if I bring out the summation, I'm going to have sum of n from 0 to infinity of integral from 0 to 1 natural log of x raised to the power of a multiplied by x raised to the power of n dx. Okay, wow, is now becoming beautiful. So now we're going to solve this equation. Integral of natural log of x raised to the power of n, then multiply by x raised to the power of n. And let's do that. Let's do that. Integral from 0 to 1 natural log of x raised to the power of a multiplied by x raised to the power of n dx. So in this question here, I'm going to make a substitution. I've done a video on gamma function. You can check my previous video on gamma function. So you are going to learn much about the function. Okay, but I will introduce the function again here. I'm going to use the gamma function. How am I going to use the gamma function here? So I can make a substitution. Then what's the substitution I'm making? So I can set put natural log of x to be minus u. Okay, so the substitution that natural log of x is equal to minus u, then I can, if natural log of x is equal to minus, the basis e, which is the u-like constant, then x will be equal to e raised to the power of minus u. Okay, then you differentiate. That will be dx is equal to, if you differentiate e raised to the power of minus u, that will be minus e raised to the power of minus u, the u. But don't forget that the limit is going to change. Okay, so at x is equal to 1, so that will be 0, that will be natural log of 1, which is 0. And at x is equal to 0, natural log of 0, and that one is infinity. Okay, so the limit is going to change from 0 to infinity. Then if the limit changes from 0 to infinity, we are going to have integral, this is now infinity, this is 0. Natural log of x is now minus u, but don't forget it's raised to the power of a, and then x is now e raised to the power of minus u. Don't forget this is raised to the power of n, and our dx is now minus e raised to the power of minus u, the u. Okay, now because of this minus, if you have integral from b to a, you have integral from b to a of minus f of x dx. So I can say this is equal to integral from a to b of f of x dx. So this sign, we change the limits. So b will come up and a is going to come down. So that's what's going to happen there also. All right, so the integral is going to change to integral from 0 to infinity of minus u raised to the power of a e raised to the power of minus u n multiplied by e raised to the power of minus u, the u. According to the law of indices, if we have minus x raised to the power of a, this is going to give us minus 1 raised to the power of a x raised to the power of a. So I can write this as I write that as minus 1 raised to the power of a, so integral from 0 to infinity minus 1 raised to the power of a u raised to the power of a, and you apply the law of indices here, so that will be e raised to the power of minus u into bracket n plus 1 u. Now don't forget, minus 1 raised to the power of a is a constant, so I'm going to bring that out. So I'm going to have minus 1 raised to the power of a multiplied by the integral from 0 to infinity u raised to the power of a e raised to the power of minus u into bracket n plus 1 the u. All right, this is now nice. We have this integral right here, which is minus 1 raised to the power of a u raised to the power of a e raised to the power of minus u n plus 1 the u. So I'm going to make another substitution. And what substitution am I making? So I'm going to have this. Let me cancel this. Forget we have minus 1 raised to the power of a integral from 0 to infinity u raised to the power of a, then e raised to the power of minus u into bracket n plus 1 du. That's where we stopped. So I'm going to make another substitution. I'm going to say let's u into bracket n plus 1 to be equal to, you can use any letter you like. I'm going to use x. So put u into bracket n plus 1 to be x, then you differentiate and make u the subject of the formula. So if we make u the subject of the formula, we are going to say u is equal to x over n plus 1, then you differentiate, so that will be du is equal to dx over n plus 1. All right, so the limit is not changing, because if you put 0, it will be 0, and if you put infinity, it will be infinity. The limit is not changing at all. So I'm going to have minus 1 raised to the power of a integral from 0 to infinity. So u is now x over n plus 1. That will be x over n plus 1. Don't forget, raised to the power of a, and then u into bracket n plus 1 is now x multiplied by e raised to the power of minus x. Then the u is now the x over n plus 1. Okay, so we have this now. And the integral is now becoming good and nice. Let me count this. So from a previous notes, I have these. I'm going to write that in the next page. The next page, so that would be minus 1 raised to the power of a integral from 0 to infinity of x over n plus 1 raised to the power of a x over n plus 1 raised to the power of a e raised to the power of minus x dx over n plus 1. All right, so we're going to apply the law of indices here also. So this will be minus 1 raised to the power of a integral from 0 to infinity x raised to the power of a over n plus 1 raised to the power of a multiplied by n plus 1. That will be n plus 1 raised to the power of a plus 1 e raised to the power of minus x dx. Then we bring out the constant, and then the constant, which is n plus 1 raised to the power of a plus 1. So we are going to have minus 1 raised to the power of a over n plus 1 raised to the power of a plus 1. Then multiply by integral from 0 to infinity x raised to the power of a e raised to the power of minus x dx. So this is now the function of our gamma, gamma function. Okay, and then we know integral of x raised to the power of e multiplied by e raised to the power of minus x from 0 to infinity dx. So this is just gamma of a plus 1. Okay, you can check my previous video on gamma function. So this is just gamma a plus 1. So I'm going to have minus 1 raised to the power of a multiplied by gamma of a plus 1 over n plus 1 raised to the power of a plus 1. We are not done yet because from this place we are having summation. So I have to include the summation for us to complete the work. So let us input the summation. So inputting the summation, we are going to have sum of n from 0 to infinity of minus 1 raised to the power of a multiplied by the gamma of a plus 1 over n plus 1 raised to the power of a plus 1, which is the answer we got here. All right. So then we know that minus 1 raised to the power of a multiplied by gamma of a plus 1 is also a constant. So I can bring out minus 1 raised to the power of a gamma of a plus 1. So I'm going to have minus 1 raised to the power of a multiplied by gamma of a plus 1, then multiplied by the sum of n from 0 to infinity of 1 over n plus 1 raised to the power of a plus 1. Now, we know this sum is very unique. Okay, it's very unique. How? Because the sum of n from 0 to infinity of 1 over n plus 1 raised to the power of s is equal to zeta of s. All right, so this definitely will be zeta of a plus 1. So I'm going to have minus 1 raised to the power of a multiplied by gamma of a plus 1 multiplied by zeta of a plus 1. But I would like to give you guys one property of the gamma function. Now, gamma function, if you have gamma of a plus 1, this is going to give us a multiplied by gamma of a. Okay, and then more also, gamma of a is equal to a minus 1 factorial. All right, then if I say gamma of a is equal to a minus 1 factorial, and then my a is now a plus 1, so that will be a plus 1 minus 1 factorial. So this will be equal to a factorial. Okay, so definitely gamma of a plus 1 will be a factorial. So if gamma of a plus 1 is a factorial, then we are going to have our answer, which is minus 1 raised to the power of a multiplied by a factorial multiplied by zeta of a plus 1. Therefore, we've generalized a logarithmic integral, which is integral from 0 to 1 of natural log of x raised to the power of a over 1 minus x dx to be equal to, minus 1 raised to the power of a multiplied by a factorial multiplied by the zeta function of a plus 1. Thank you for watching. Don't forget to subscribe to my channel, like my videos, share and comment. Thanks for watching. See you in our next class. Bye.